My name is John Maddog Hall. I'm the Executive Director of Linux International. I started programming in 1969, so this is my 46th year of writing programs.
You got the nickname John Maddog because of your lack of temper back when you were teaching, right?
What was happening was I was teaching and I was 27 years old. I didn't have as much control over my temper as I do now. And I had a dean of instruction who saw teaching a different way than I did. He thought that the students should be way down here and the professor should be way up there, and that you maintain this distance between you. And I thought the best way of teaching students was to take them out for beer and pizza after class. So I would come in a t-shirt and shorts. The dean would come in a full suit, white shirt, tie in the middle of the summer, no air conditioning and stuff, and sweat pouring off of him. And I would look at him and say, "This is crazy, right?" And we would have discussions about teaching students and disagreements about how to grade and things like that. And sometimes we would get to really heated arguments. And I remember one time I was fired 4 times in one day. Fortunately, he hired me back 5 times in one day. It was during that particular conversation that the students decided that these talks were too hot for mad dogs and Englishmen. Since the dean was British, I was the mad dog. Now, since that time, I've realized that when you lose your temper, you lose the argument. And, so it doesn't do you any good to lose your temper. So I've made it a point of not losing my temper. I still have the temper. I still feel it inside of me when somebody does something incredibly stupid. And, but I don't lose my temper. In fact, what I try and do is get the other person to lose their temper, and then they lose the argument. So the interesting thing was that back in the early days of computers, you were making the computers out of discrete components. I mean, I actually created a computer out of relays one time. Okay, the relays were used to control a large machine, but the logic was built using relays. And they, of course, were incredibly expensive and slow by any standards. And then after that was electronics, where you used tubes to replace the relays, and you created your adder circuits and things like that. And then after that became transistors. But they were still discrete transistors. You could wire them together and see how the computer worked. But then they started putting the discrete transistors into these things called integrated circuits. And you had this thing called an arithmetic logic unit and a controller and stuff. And you had to have faith that there was this thing going on inside of it. And back in those days, all the computers still had lights and switches on the front panel because you only ran one program at a time. And so you could watch the lights and you could see what they were doing and stuff, right? You could tell if your program was in an infinite loop because the lights would just have this one pattern all the time. But then they started running multiple programs inside the computer. It didn't make any sense to have the lights, so they took all the lights off and all the switches off, and now it was another leap of faith that something was going on inside of the computer. You fast forward a few years, and you have kids who they buy a laptop computer, and there's this thing on it that says, if you open this up, you void your warranty. And instead of taking a piece of source code in the program, they buy a game and they stick it in. And they've lost being able to see what a syntax error is, or what a buffer overflow is, or anything like that. And they write a little bit of HTML and they think they're a programmer. In a way, in essence, they are a programmer, but they're not a good programmer. They're not somebody who's going to write some really exquisite code. And they don't understand how the computer works underneath of all of that, and that's a problem. And this is exactly why the professors at the University of Cambridge created the Raspberry Pi. They wanted to create a computer that does not come in a case, a computer that you had to run this operating system where all the source code was available. And you had this little strip of pins on it, general purpose I/O pins, that you could then take off to a circuit board and build a discrete circuit that's going to run your motor, it's going to accept the data coming in and make it acceptable to the computer so the computer could then use that data and manipulate it. But all this stuff is not hidden anymore. It's right there in the young person's face. And the kids loved it, because it really showed them what a computer was. And you go out there and you look at the people using the Raspberry Pis and the wonderful things they've done with them. And that's a great thing. Is it that hard to send Raspberry Pis all over there? And the BBC, the British Broadcasting Company, has come out with this new computer called the Microbit that's so inexpensive that they're going to give one to every 7th grade student in all of the United Kingdom. Now, you can get sponsors to do that, a bank or a government or something like that. It isn't that expensive. And when you think about the opposite of what if they don't have that education, what if they don't have that training, how much are you wasting? So part of a project I'm working on thinks about how inefficient the people use their computers today. They really do use them inefficiently. And if we say that each computer, each personal computer, desktop computer a person uses, that it wastes $5 or 15 minutes of their time every day. There are 2 billion computers on the surface of the earth. That means we're wasting $10 billion every day because the computers don't work the way they should. And why don't we see this? Because we're only wasting it $5 at a time. But if you have 300 systems set up in a call center, and each one of them wastes 15 minutes a day because maybe you didn't do your backup, so you didn't get rid of the spam or the viruses on them, that's like 9 people never came into work. And if you were the manager of those 300 people and 9 people didn't show up, they're not on vacation, they're not getting training, they're not sick, they just didn't show up, you'd be really upset. But nobody gets upset about the fact that these computers are wasting 15 minutes a day. What would happen if now you trained those people better and you took one person out and you say, you're going to be the person responsible for giving the training, going around and helping these other people use the computer better. And you were able to reduce that 15 minutes a day to 5 minutes a day. Now all of a sudden it's like 6 people just showed up. You've got 6 people back. But see, people don't think that way. That's a problem. So my goal, over the last 45 years that I've been in the computer field, when I started, in order to touch that computer, you had to have a master's degree or a PhD in computer science. Why? Because that computer could only run one program at a time, and it cost $2.5 million. And so if your program wasn't efficient, you were wasting large amounts of money. So after a while, they moved that expertise down to the computer center. That's where they had all the expertise. And the people that were writing the programs got less training. And then the expertise was moved out to places like IBM and Microsoft, the vendor. You call up the vendor to ask the question. And then the vendor wouldn't talk to you anymore. So you have to call up the call center to ask the question. These people are reading from a script that is given to them. Now, in that call center, they have a person whose job is to hire people. And their job is to hire the person they can get for the least amount of money to be in that call center. And to give them the least amount of training in order to keep their customers happy. So their job is to keep the costs down. And in the customer business, there's another person, they're called the purchasing agent. And their job is to find the cheapest support they can possibly get. Do you see the problem? The one person that's left out of this little thing is the end user, who now has to sit on the phone for 20 minutes while the person asks them, is your mouse plugged in? Have you rebooted your system? When was the last time you upgraded it and stuff? When I get somebody like that on the phone, I say, hi, I have a master's degree in computer science. I built computers from bare bones, and I know more about computers. If you pick up that script and start reading it again, I'm going to reach out across that phone and strangle you. Project Cal I've been working on for 9 years, and it started off with a set of goals. One goal was to help people make money with free software. Now, there's many ways you can make money with free software, and all I have to say to you is, if your name is not Bill Gates or Steve Jobs or Larry Ellison, how do you make money with their software? And the answer is you install it and you charge people for installation. You integrate it with things, you charge them for the integration. You teach them how to use it, you charge them for the courses. These are all ways you make money with proprietary software if you're not one of the people in that company. And you can do all of that stuff with free software. You can pull it down, you can charge people for installation, you can teach them how to use it, you can charge them for that, you can help them integrate it to solve a problem. I'm going to say something that may be astounding to you, but nobody in the world ever bought a computer. Nobody ever bought software. There's nobody that has a box of software stuck up on their wall with 2 candles on either side, like a shrine. There's nobody that has a computer like that, unless of course it's one of the first Apples. That's worth it, okay? But anybody else, forget it, right? What they buy is a solution to a problem. And even if that problem is, I want to play a game, the solution is playing the game, not the computer itself, not the software. And so, if you could give the same solution with free software, then that is what the person's buying a solution. And I happen to think you could buy a better solution with free software because you can integrate the software better and you can have it do exactly what you want. Now, coming to Latin America, we have to think about the fact that Latin America sends millions of dollars outside of Latin America to the United States, to places like Microsoft and Oracle and stuff, when they could be using Linux or BSD, or one of the free operating systems. And for a database, they could be using MySQL or Postgres. Now, granted, every once in a while you might need to use Oracle for some feature or something like that, but you don't have to send that much money to Larry. You can have a little shorter boat. And that money that you keep inside of Mexico, for example, that money then pays Mexican programmers to make the changes you need. And when they pay a Mexican programmer, then they buy Mexican food, Mexican housing, and pay Mexican taxes. But every time you send that money outside, hey, let me tell you, there's only so many tortillas that Bill Gates is going to eat. So only so much, tequila. A lot of people in the United States look at Latin America and they think of Brazilian rainforests, or they think of deserts and stuff like that. And they don't realize that 86% of the people in Latin America live in a city environment. That Mexico City is the largest city in the Western Hemisphere, and Sao Paulo is the second largest city in the Western Hemisphere, and New York is somewhere way down the list. They don't think of that. And they don't think of the fact that when small business is at its best, it produces 90% of the intellectual property, that it also produces around 86% of the gross domestic product in private sector, non-military, non-farming, okay? So there's a lot that could be done if you made things very efficient. And there's a lot that could be done in Latin America. We started to develop this, and we ran into a problem, because the best time of putting in this networking is when the building is being built, and then it's a 2-year span of time from the time the building is built to the time we have first occupancy. So what does the person do in between? And we went through several cycles of this, and then we came up with the latest round of Project Kawa, which is to concentrate on students. In Latin America, a lot of the universities are free. If it's a public university, the tuition is free. If it's a private university, a lot of times there's scholarships, either private scholarships or government scholarships for the students. But they still can't afford to go to school. Why? Because they come from a small town outside of the city where the university is. And they come from maybe a single parent family. They've been working to help to support their family. And now you're taking them out, and they have to get an apartment, and they have to buy food, and they have to get transportation from their apartment to the school, and they have to buy books, and they have to buy computers, and they don't have that money. So maybe they get a job flipping hamburgers at McDonald's, but that pays a very small amount of money and isn't exactly in their realm of what they want to do. So we actually got our inspiration from a young university student who had set up a business of going and supporting very small businesses. He specialized in car driving schools, which there's a lot in Sao Paulo. And he would go in there and spend 3 hours with each one of them every week doing anything they needed to make sure their computer systems were up and running. So he'd look at all of their error logs, he would go in and make sure their disks had plenty of space on them. He would make sure they had all the right device drivers installed. He would make sure they had all the latest patches installed. He would rewire their entire network to make it safe and secure. And all of these things he had learned on his own, just because he was interested in computers. He didn't have to take courses on how to do this. He could pick up a book and read it and learn it on his own. He'd been using computers since he was 9 years old. So we looked at this and we thought this was a great idea. And so we twisted Project Cal around to say, we're not going to teach you about computers. We're going to teach you about business. We're going to teach you how to go out and sell yourself. We're going to teach you how to find out what your capabilities are. We're going to teach you what a contract is. We're going to teach you all these things. And then you can start your own business. And guess what? This isn't going to cost you anything. Nothing. Okay? Because we figured out a way of teaching you this without charging you anything. And we will supply you with certain tools over the web so that you can help to keep track of your systems. And then, when you go into university, you set this up. This gives you the money to help you get through university. As you get into your senior year, you find an incoming freshman, and you say, okay, I built this business up. I found all the customers. But I have a lot of exams, final papers I have to do. So what you do is you come in and you start taking over some of my customers. And then as I go through the senior year, at the end, you own the business and I'm out of here. And you paid me a certain amount of money for my help and my guidance and everything else to get through. So this also solves one other problem, because in the sophomore year, if the student goes to somebody who's building a new building and says, you put in all the networking and everything, and now I will go away, and in my senior year I'll come back, and I'll say, I will buy the server systems and all the thin clients to go in there, and then this will be my job and my business is taking care of the people in your building. Because you don't buy an office building without electricity, you don't buy an office building without water, and you don't buy an office building without sewage, and you don't buy an office building without computing facilities. We're teaching business stuff. There's a lot of stuff that can be taught just by putting this stuff up on the web and allowing people to do that. We also have mentor programs of Project Cal entrepreneurs teaching other Project Cal entrepreneurs. We have forums where they can ask questions and get help from the other Project Cal entrepreneurs. But if you start having enough Project Cal entrepreneurs, you find there's an awful lot of people that come to this website and they are very interested in Project Cal entrepreneurs and stuff, and there's a whole bunch of people who will actually advertise on your website, and that advertisement is what funds Project Cal. So the entrepreneurs don't have to pay anything. You know, they just go to the website, they get their information. You know, even every once in a while we can have maybe a town or a city sponsor an on-site class if they have 40 or 50 entrepreneurs that want to get started. But that's not the entrepreneurs that are paying. It's the government that pays, because the government knows that once these people start working, they'll be paying taxes. So the government wants to see this. It means that these people are not going to be on the dole, they're going to have jobs. So you save money lots of ways. I think the best programmers in the world will be able to teach themselves programming. I've run across many of them. A 12-and-a-half-year-old kid that has his own distribution of Linux It was the first distribution of Linux, which allowed a person to log in just by facial recognition. He did this at the age of 12 and a half. By the time I met him at 15, he had 20,000 people using his distribution. His father, who had worked for IBM for 30 years, had quit IBM and was working for his son. He's since started several different companies, but he's really, really great. I met another kid who created the first distribution that was a live distribution. It ran off of a CD, and you didn't have to install it onto your system. And he called it the FAT system, P-H-A-T. And he did this at the age of 15. The guy who's in charge of Asterisk never took a course in computer science. He was 19 when he wrote Asterisk. He was a university student. And today, his company employs 350 people. He's a multi-millionaire. He started another company doing avionics, free software. And, you know, these people do it themselves. But the problem that they have is they tend to have a very deep knowledge of one subject, and you don't necessarily have a broader knowledge of everything else they need. In the case of the Project Carol entrepreneurs, they have a very good knowledge of computers, but they don't know how to start a business. They don't know how to sell themselves. They don't know about things like professional insurance to protect you in case you do something wrong and your customer decides to sue you. Just because you're 19 years old doesn't mean your customer isn't going to sue you. So these are things that they need that more experienced people know and can pass that along to less experienced people. But I think that the only way to really get an idea of how a computer works is to learn something all the way down at the very bottom. That take two transistors you put together, you create a flip-flop. You take two flip-flops put together, you have a half-adder. Take two half-adders put together, you have a full adder. Take a bunch of full adders together, you have a register. Take a bunch of registers, you have an ALU. Take the ALU and the timer and the controller, and now you have a CPU. You take the CPU and some memory, and now you have the beginning of a computer system. Add a GPU in there for fun, okay? And now you have a system on a chip. And now you put that system on a chip on a motherboard, you know. But when something new comes along, you could think in your mind all the way down. You know, I know what's at the bottom of that. It's a couple of transistors. And those transistors, it takes time for the electricity to travel from one place to the other. And it takes time for the charge to build up on that transistor. That's why your nanosecond is so important, okay? Because if you don't give that computer system that nanosecond to do that, if you turn the clock up too much, then it won't have the time for the electricity to travel that distance you want the time for it to build up. It's that bottom type of training that's necessary. And what's happening is people taking a shortcut. They're saying, hey, all you have to know is Java. All you have to know is HTML, you know? And that's, if you want to be an average programmer, maybe. But who wants to be average? That's disgusting. You know, I want to be the best.